notes on paper. Phone in the home, Aaron. Phone in the home.
Yeah. Well, you should be treated like one until you get better grades.
Mm-hmm.
I have a screen time too.
At least I don't break like one like Nick.
Okay, just to recap, I actually want you guys to find this one on your own. I want you to find or evaluate the sine of 2 pi over 3. You're doing this on your own. So this is what we were doing last week. It's what we had an extra practice day on Friday. I'll give you a couple minutes and then we'll go over it together just to refresh your memory after the weekend.
Oh yeah, Nick had a great weekend.
Ethan.
I'm getting like a
Lock
2
in.
billion high score.
What is your high score?
2 billion.
No, it's
20,000.
Oh.
Mine's 122,000.
Mine's 60.
Mine's like
Nick, do you just
75.
not do anything because you don't have paper? If I give you paper, will you do something? I'm asking in radians.
Oh.
Well, this is in radians, but it's not 120 now.
You need to put an angle. You need to find
I want you to evaluate it.
That means find a degree, right?
Is it pi over 180 or 180 over pi?
I'm not asking you guys to change it to degrees.
Okay.
Oh, we're just evaluating it?
Guys,
Okay.
this is where we make our axes.
Angle, I remember that. Except,
And now everything's in radians. So this is 0. This is 2 pi. What is the 90 degrees in radians?
1 over 2.
What about the 180 in radians?
1.
Pi.
3
And,
pi.
yep, 3/2 pi. But now what we want to do, if possible, we want to make all of these have the same denominator as the denominator of the angle we're evaluating. So the angle we're evaluating has a denominator of 3. That means we want all of our key points to have a denominator of 3. So this is going to be 0 pi over 3 and 6 pi over 3. Can I make a denominator of 2 into a denominator of 3? No, so I leave that alone. What about pi? How do I make that into a denominator of 3?
3 over 3.
3 pi over 3. And I can't change a denominator of 2 once again into a denominator of 3, so I leave that as it is. So now what we're looking at is 2 pi over 3. Well, do we agree right here is 3 pi over 3? So we're going to be right before that, so we're in the second quadrant. We're in the second quadrant. And that's where I make my triangle. How do I know what my key angle is in this triangle? Because of the 3. So what do? 180 divided by 3, which is 60 degrees. So now we know we're dealing with a 30, 60, 90 triangle. Across from the 30 is 1. Across from the 60 is root 3. Across from the 90 is 2. Are any of these numbers negative?
Yes.
The 1 is negative, yep. So now we go back to SOHCAHTOA. Everything's in reference to the 60-degree angle. So the sine of 2 pi over 3 is going to be our opposite, which is root 3, over our hypotenuse, which is 2. I'll come back to you now. We're good? Because I'm going to step it up.
Yeah, that's what I thought. Everyone's going to be so on.
Okay?
You're so ready to learn.
So ready to learn. Okay. So now for the next one, let's say I have the sine of 115 pi over 3.
need to go around like 17 billion times.
I'm so happy you said we're going to need to go around a lot of times. You're absolutely right. And you guys don't have to write this down. This is just an explanation for you. So here is 0 pi over 3. This would be 6 pi over 3, a half pi, 3 pi over 3, and 3 halves pi. So Ethan said it. Ethan said we're going to have to go around a zillion times. And every time we go a full circle around, how many pi's am I subtracting?
2.
2 pi's, but with the denominator, wouldn't it be 6 pi over 3? So it would be 115 over 3 pi minus 6 pi over 3. And then if we go another full circle around, what else would I be doing? Subtracting another 6 pi over 3. So essentially what we're doing is we're taking this 115 and we're dividing it by 6. Do you guys see that? We're taking that 115 and we're dividing it by 6 to get the smallest number possible. So I'm going to put a little star here. This you should write down. Put a star. When dealing with very big numerator, divide the numerator by twice the denominator. Why twice? Why twice the denominator, not just the denominator? Because a full circle is 2 pi. So we are always twicing that denominator to get that full circle. So I'll let you write this down, and then I'll show you how we're going to go about this. Ready? Okay. So what I'm going to do is I'm going to take that 115, the big numerator, and I'm going to divide it by twice the denominator, which is 6. And we're going to do our long division like back in 3rd grade, and we're going to say 6 goes into 11 once. 11 minus 6 is 5. Bring down the other 5. 6 goes into 55 9 times. And don't we have a remainder of 1? Okay, so now what we're going to do is put the remainder over original denominator. So what this is saying is we're going to make 19 whole revolutions. So we're going to go around that circle, not a trillion times, like Ethan said, but 19 times, which is still left. So we're going to go around that whole circle 19 times. But then there's going to be 1 pi over 3 left over. So now what we're going to find is the sign of 1 pi over 3. So go back to our axes. Which quadrant am I in if I'm trying to find the sign of 1 pi over 3?
1.
The first quadrant, you got it. What's my reference angle and how do you know? It is 60. How do you know?
Because you're dividing by 3.
Good, because we're dividing by 3. So we're a 30, 60, 90. Across from 30 is 1. Across from 60 is root 3. Across from 90 is 2. Are any of these numbers negative? No. So now I want the sine of 60, which is going to be the opposite, which is root 3, over the hypotenuse, which is 2. So the sine of pi over 3 is root 3 over 2. All right, we're just going to keep doing more of these. This is what today's lesson is.
So you're just dividing by 180 by 3. How do you get 60 on the interior angle again?
Yep, so you take the denominator of our angle and divide it into 180.
Oh.
So 180 divided by our denominator gives us the interior angle. Here, I'll shrink it down so you can see it all. Aaron?
Can I do that real quick?
Sure. No phone. You got it, Izzy?
Yeah.
All right, we ready for our next one? So we're doing this again. So now I want us to evaluate the cosine of 217 pi over 4. Ethan?
Yeah.
Our numerator is really big, so what do we have to do?
Go around multiple times.
So how do I figure that out?
You make everything into the denominator 4, and then you just go around and around.
I want to figure out how many times I'm going around and what the remainder is, because the remainder will tell us which quadrant to be in. So how do I figure out how many times I'm going around and what the remainder is? Long division. So I'm going to take that 217, but I'm not dividing it by 4. What am I dividing it by? 8. Why 8 and not 4?
To make it look prettier.
Because when we make everything have a denominator of 4, this becomes 0 pi over 4, and this becomes 8 pi over 4, right? The 2 pi becomes 8 pi over 4. So essentially, every full revolution is 8 pi over 4. So we would do 217 pi over 4 minus 8 pi over 4, minus another 8 pi over 4, minus another 8 pi over 4. So we're really taking 217 and dividing it by 8. We're always dividing by double the denominator because that's going to be a full revolution.
Okay.
So we're going to say 8 goes into 217, 8 goes into 21 twice. So we're going to have 8 goes into 57 7 times. And now our remainder is 1. So what does this mean? This means for 217 pi over 4, I have to make 27 full revolutions, and then I'm going to have 1 pi over 4, your original, left over. So this is telling us 27 full revolutions. You guys want me to write this out in words or no? You don't care? No? Sure. So this tells us 27 full revolutions. And then there's going to be our remainder, which is 1, will be 1 pi over 4 left over. So now let's let's finish labeling our axes, if I can speak properly. So we're pi over 2, pi over 2 is going to become 2 pi over 4. Pi will be 4 pi over 4. And then 3/2 pi will be 6 pi over 4. Okay, so now I want the cosine of my remainder. What's my remainder? 1 pi over 4. So which quadrant am I in for 1 pi over 4? Once again, the first quadrant. Connor, what's my reference angle?
The interior one to the one touching the origin.
Yep, and what's that number going to be?
45.
45, because we did 180 divided by 4. So in a 45, 45, 90, we have 1, 1, and the square root of 2. Over here. So now if we want the cosine of pi over 4, we're going to put the adjacent over the hypotenuse. Can I leave it like this? No. So it's going to be root 2 over 2. All right, I'm giving you guys this one to try on your own. You ready? Anybody still copying? So I want you to evaluate 117 pi over 4. Yeah, that's a 4. Oh, it's number 4 you're saying? Okay. As soon as you're done, raise your hand. I'll come help. I'll check you. If you need help, raise your hand. I'll come help you.
Not the same answer.
Oh, I don't know the answer. Let me see the answer.
It's just negative root 2 over 2.
Positive or negative?
Negative.
Okay, you got it. No David either?
So I wish I had a free day. I mean, no one's here.
They're gonna have to watch my video.
You should have to like leave a hint in the video, so like something to make sure that they watched it.
And then
Like they have to come in with a code word.
yeah, like Apple or something, and you say in the video, and then you come in here and say, what was the word I said in the video?
I love this to make sure they watched it, but then what's their consequence if they didn't watch
No
it?
consequences because I don't watch it.
They have to put their phone in the home for a week?
But the thing is, like, sometimes I don't watch it, but I figure it out.
You were making fun of people like the phone in the phone holder all of a sudden.
Because I'm mad that you're all on your phone.
Miss Eggs, you post this anywhere for this unit yet?
I don't know.
Can you post it
We lost our sign somewhere.
No, it's doing like a
We should have been in this quadrant. Where's your division? 14. your remainder was 5, so that's 5 pi over 4. So this is 4 pi over 4, right? So that would have been like 3 pi over 4. You want to go down here. Oh, you always go back to your original denominator. Perfect. Yeah, is that a negative?
Mhm.
Perfect.
I believe this.
Your original denominator and dividing by 100, or less than
Then the
5
first
by
day
that
period
one.
is
You
four.
want to divide by 4, which is
Is that the first day of period?
of the denominator.
That was much time. 12. It's 2 days.
Chris Garvin will pay period Wednesday.
I mean, he should.
Check my work rate.
I mean, I don't think he's not young. He's not old. He's like 30. He was injured.
This is perfect, this is
He's been
perfect,
injured the last 3
but your
seasons.
sign is not perfect. So over
His sign
here,
is also
remember
very
this
good.
is negative and this is negative, which means this would be a negative.
It's 29
Can we just have the quiz already? I
Yeah,
think
he's
it's
gonna
90
turn
for my
30.
phone.
When he turns 30.
next year.
Okay.
I mean,
I checked this, I checked this.
you know who else is 29? Debo Samuel. Terry.
People send me this one.
Debo Samuel's washed.
So
But he had his Hall of Fame year, and then
Terry, he's
He's a dog.
he's the best guy.
You don't see what happens.
He's been a dog. He has like 6 straight seasons.
I thought Miles Garrett was gone.
Whatever you were here is the same.
I mean, he basically is still a top.
No, he
Now
just
he's-
got paid humongous
yeah,
contract.
he's got.
I know, but he's stuck
Money.
in, like, he's stuck in Cleveland.
And then divide.
I mean, yeah, I guess, but
He's making $40 million a year. Yeah, he's stuck in Cleveland.
Twice.
A 40 million
Yeah,
a year
really.
as a line, as a defensive lineman is devious work.
Oh, we divided it by
Exactly.
4.
40
I mean,
million.
Divided by
That's
12.
quarterback.
Those are the highest 2 paid positions, quarterbacks and D. And then wide receivers.
Double would be 2 pi.
No, it was normally quarterbacks and
It's
receivers.
gonna make a remainder of 5.
Yeah, usually it's like that. Quarterbacks and receivers.
Yeah, but
Oh, you're figuring it
now
out.
Max Crosby and Miles Garrett are the 2 highest paid non-quarterbacks in the league.
That's true.
So, Lord, do you have to have a remainder of
Is
the
that
No, so that's a
3
remainder
of the
of
4
5. Pi
highest
over 4,
non-QB
yeah.
contracts with the eliminator, right?
And now we have to figure out which quadrant that's gonna be in.
Garrett, Crosby, Travis, and Bosa.
here?
Yeah, they pay CD Lamb so much
CD
money.
Lamb is like,
And then I
well, it's I don't care. The Cowboys can pay him $100 million a year.
Cowboys suck. There's a Cowboys fan here.
ain't nobody.
Oh, good. Jesus.
Yeah, I hate the Cowboys. I hate the Cowboys. I hate the Eagles. Fuck the Giants, but I can tolerate them. Yeah.
I mean, at some point you gotta have pity for the Giants.
Like,
it's not
no,
fair.
I hate the Giants, but I can tolerate them. Like, you know, because, you know,
I can't remember the last time the Giants have done good. Or the Jets.
when they won the Super Bowl in 18 years ago.
No, they,
Well, the
then
Jets,
they got that
when they
one
won the
playoff
Super
win
Bowl,
against the
Jordan
Vikings.
No, the Jets was like 2011 or something like
Yeah,
that.
that's perfect.
When
Now you're going to 5 pi over 4, so which
Same
quadrant would
case.
that be in? Yeah, perfect.
For us to the AFC Championship.
Off on
You gonna bring that up?
Yeah.
With the
He
Patriot
was,
fan right
he
there?
was a quarterback
You
for
thought
us.
With the Patriot fan right there? You're gonna bring that up? You serious?
Wait, what? That was it versus the Patriots?
Yeah.
Oh.
And won't both those ones be negative, because you're negative x and negative y?
Mark Sanchez is on lineman to his base.
The Brickshaw Ferguson, right? Says
The freaking
Jets legend of Brickshaw Ferguson. Oh my god.
So you'd write pi of 117
DJ
pi
Reeves.
over 4.
Wait, can I get my
So
phone
go
up?
back to the original. Sometimes I write it back, but the most correct way is to go back to the original.
DJ Reeves.
Oh, shut.
He's not staying in New York.
Yo, why did you just... No, DJ Reed is not leaving. I'm calling him.
He's a free agent.
Yeah, they're gonna re-sign him. DJ Reed,
Who would want to stay there?
our defense was not the problem.
Yeah, your entire team is a problem.
The offense was.
That's
Our
not
defense
much
was
Your
sense.
entire team is
definitely
a
not the
problem.
problem. This sounds work. Can I get my phone?
No, we're not done.
We're not?
No, we're going to do more practice. So this is going to be negative root 2 over 2. Every single person had gotten this. Let's see this one.
No one wants to go. Yeah. We just go ahead and play coach.
So question for you. Do I need to do that thing where we divide by double the denominator? Do I need to do that here? No, we only do that when?
When it's a bigger number.
When it's a bigger number. So for this one, we just start labeling. So this is 0 pi over 6 and 12 pi over 6. But because it's negative, right, don't I now move clockwise instead of counterclockwise? So the 90, the pi over 2, will be down here. But to make a denominator of 6, I'm going to have 3 pi over 6. This is 6 pi over 6. And then we have the 3/2 pi, which is going to be 9 pi over 6. So which quadrant am I going to be in for negative 7 pi over 6? For going counterclockwise. Wouldn't it be right here between 6 pi over 6 and 9 pi over 6? And then our reference angle is 30. Across from the 30 is 1. Across from the 60 is root 3. Across from the 90 is 2. Secant is related to which main trig function?
Cosine.
Cosine. And cosine is a over h, so secant is h over a. So the secant of negative 7 pi over 6 will be hypotenuse, which is 2, over adjacent, which is root 3. Can I leave it, oops, sorry, isn't this a negative root 3? Can I leave it like this?
No.
No, we have to rationalize. So the secant of negative 7 pi over 6 will be a negative 2 root 3 over 3. Okay, next one. I want the sine of 5 pi. Is this any special triangle? It is a special angle. It is a special angle. How do you know that? Because there's no what? Denominator. So what does that mean? It's going to be on one of the axes. So this is 0 pi, comma 2 pi. This is pi over 2. This is just pi. And this is 3 over 2 pi. So we want the unit circle. So this is the point 1, 0, the point 0, 1, negative 1, 0, 0, negative 1. Where would 5 pi bring us? Is it going to make it all the way around to 2 pi again? No, where's it going to bring us? Good, just to pi because it's odd. So now I want the sine of pi, and sine is y over r. What's the y coordinate here? 0. What's r always? 1. So the sine of 5 pi is 0. What's wrong, Connor?
I don't know, I just zoned out for a second.
Okay, did you know why we're at pi?
That doesn't be the denominator is.
No, okay. So one full revolution would bring us to 2 pi, right? And then another full revolution would bring us to 4 pi.
Oh, and then 1 half revolution.
And then just a half revolution would bring us to pi.
Okay.
So that's how we know we're at pi. And then we use the point for pi, which is -1, 0, and sine is y over r, so the y coordinate over the radius. Okay, so now I'm going to give you guys 3 problems to do. Once you do the 3 problems, we will officially be done.
Is it in this quadrant?
For which one? Number 1. Which quadrant did you say? Correct.
I didn't want to say that loud.
What's the equation thingy for cosine? What is it? Something
Adjacent over hypotenuse,
No, like the.
x over r.
Oh yeah, is that what it is?
Mm-hmm.
That's right.
Yes. 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 Good job, Nick. We're expecting 100.
When's the test?
Friday, I think.
This one.
I think so. Because I think we have one more day of learning, and then review, and then test.
Can you pass me a marker? Thanks.
So that means I can go on phone and say, right?
Yep, you're all done. You could go on your phone. Alright, so my video's not going to get too long. I'm going to give them the answers at home. And then I'm shutting off.